The butterfly model and the Dovetail Theorem. Lesson. So the butterfly model and the Dovetail Theorem are two very important parts of geometry that we have to look at throughout our Math Olympiad series. So I will be putting the link to their more basic videos and lessons that we covered before in the description down below. So it's fine if you didn't watch those, you can go over it and look at that because in here I will be going through what each model is about as well. It's just that this will be more advanced, right? This is 6th grade. So let's get started. Well, our first one is the butterfly model number 1, and as you can see, it is a quadrilateral split into 4 parts, 4 triangles. So quadrilateral ABCD is split by 2 lines from BD and AC intersecting at O, and you have S1, S2, S3, and S4. So what I want to tell you is S1 times S3 is equal to S2 times S4. And S1 plus S2, that ratio to S3 plus S4 is equal to the ratio of AO to OC. Won't spend any time trying to prove those because in the previous lesson I have. Okay, now here's our butterfly model number 2. Oh, and one thing why it's called the butterfly model is you can almost see, like this is the body and these are the wings, if you will. Okay, so here's the butterfly model number 2, and it's a quadrilateral, but it's a bit more special because this is a perfect trapezoid. And there are 2 new things here, as you can see. Lowercase a and lowercase b is the top and bottom sides, parallel sides of ABCD. So again, we have S1 times S3 is equal to S2 times S4, although here S2 is the same as S4. All right. And now here's the interesting part with the relationship of their areas. Their area ratio of AOD compared to BOC compared to AOB compared to DOC is the same as A squared to B squared to AB to AB. So this is A that we're talking about, this is B we're talking about. Why? Well, if this is A squared and this is B squared, these two sides, remember, multiply together 1 times 3, so A squared times B squared is equal to something else. And each of these two values have to be equal. That will have to be AB times AB. So that's why 2 and 4 are the same. Now let's move on to the Dovetail Theorem. So the Dovetail Theorem is another model in geometry, and it looks like a dovetail. And here's how. It has 3 different ways to look at it. So first, the tail for a type of bird is like this, right? So it's like almost like a scissor. It has a split in the middle. So over here, it goes like that. And basically, for this part I'm holding out right here, the area of triangle AGD to triangle AGF is the same as DG to DF to BG to GC and all of those triangles as well. And you can look at it from multiple sides. It could be facing down this ways. It can be facing the right side this ways. And if you want to look into more context about the Dovetail Theorem, you can go into the lesson video of my earlier Dovetail Theorem topic. It's going to be in the description down below if you're interested, so you can go ahead and look at that. So thank you for watching Through Inquisitive Kids, and see you in problem 1.